My name is Charifa, and I've been working with perception systems and robotics for many years. I have a bachelor degree in mechanical engineering, master's degree in mechanical engineering, and PhD in electrical engineering. Most of what I do related to computer vision related, perception related work and program management type of things. I work in a company called SSCI, Scientific System Corporation in Boston. So if I ask a question, what is an autonomous robot? The class is called perception for autonomous robot, right? So it means that it sense the environment and reason the environment, right? They have some reasoning that perceive the environment and then act upon this. Perception, perceive the environment, sense the environment, and reason the environment, and act. So autonomy refers to the system ability to accomplish goals independently or with minimal supervision of human operator. And for autonomous robot, this is general autonomy, but for autonomous robot in particular, a robot is a goal-oriented machine that can sense, reason, and act. So there are these three triangles of sensing, reasoning, and acting. And for this course, we are interested in this circle here, sensing and reasoning, not so much into acting. So you have, for example, a sensor. That sensor can be a camera, can be sonar, LiDAR, radar. Sensor is giving you a signal. You take that signal, analyze it, understand it, and then make reasoning out of it. That reasoning could be where you are in the environment. It could be, what is that object in front of me? Is that object a road or is that an obstacle? Okay? If you look at this slide in here, the picture on the left is industrial robots. These industrial robots typically just do certain tasks. They don't care if they're, for example, doing welding. The industrial robots on the left, they know where they need to go. The engineer programmed that robot to go to a certain location at a certain time and do a certain task, such as welding, painting, things like that, to assemble a car, for example. But the question, does this robot qualify as an autonomous robot? It's a pre-programmed robot, and most of the time, these robots, they don't have a sensor that will tell them whether there's no feedback loop. You see what I'm saying? So if you take the car off, they might still do welding or painting. They don't have a feedback loop sensor. They don't reason the environment. So that's why they don't qualify as autonomous robots. The robot on the bottom left, it's a robot used in usually to detect explosive, IED or something, and usually this robot is remotely controlled, right? It has a camera, the camera goes, and using the camera they can sense the environment. They don't want to send a human to check a bag whether it has explosive. It won't be a good idea, so a robot can go there and check something or detonate the explosives. Does this robot qualify as an autonomous robot? No, right? And the reason is it's remotely controlled. Right? If that robot were to do this task on its own, if you tell the robot, oh, go and find explosive, just like that, you give a high-level command and take that high-level command and execute it, then it would qualify as autonomous robot. But typically it's not the case. Well, the cases on the right, you have a Roomba, cleaning robot. That robot can take high-level commands, right? You tell the robot, clean room so-and-so, and go and clean it. It used to be an open, like a dumb robot, where it just keep running around randomly. But I think nowadays they make it more efficient, where it knows where the areas that it cleans, and it tells you whether it's done, and it'll go back to the charging station once it's done. And the right bottom, the autonomous driving modules in Tesla, for example, is it fully autonomous? No, right? Because you still require someone behind the steering wheel observing and taking action, because most of the time, most likely, if you're going from point A to point B, at some point you have to take the steering wheel and take action. So it's kind of semi-autonomous, right? I mean, they have they have autonomy levels, right? The 5 autonomy levels. And I think this is autonomy level 2 or 3, what they call it, where there's some observer, but that's ready to take action. And then level 4, when the observer are just there, but they don't need to take an action. Level 5, when it's fully autonomous. You don't need to have even an observer over there. Yeah. So, question. What would be a good definition for an engineer? The word engineer. Yeah. Find solutions to problems. Yeah, that's a good one. If I have to be more particular, I would say ideally you need to find like an optimal solution to a problem, right? Because sometimes a problem might have many solutions. Some of them will be too expensive, right? And some of them are not optimal. So finding the optimal solution is really what a mindset of an engineer should be. So in this class, you will learn a lot of tools that you can use that's related to computer vision, related to perception. So your task as an engineer is to use these tools to the best way to achieve a solution to the problem that you will be given. And this should be the mindset for you even when you go to real life project, when you have a problem you want to solve. You just want to solve the problem within the constraint, optimally, within the constraint that you have. Sometimes the constraints would be cost. You want to reduce the cost. Sometimes the constraint would be time, resources, power. You know, there are certain solutions that require you to bring a whole computer and put it in whatever machine. But is that feasible, you know, to put high-end computer in there, supercomputer? No, you know, you might need to work with just small, tiny space for your computer to run on. So there's a lot of restrictions to solve that problem.